Hello friends, today we are going to see about the topic Introduction to Data Structure from the subject Algorithm and Data Structure. There are various basic terminologies related to data structure. As if we are going to describe or define the data structure, it is of two words, data and structure. Data data is simply a value or set of values of different type, which is called as data types, like string, integer, character, etc. Whereas structure is the way of organizing the information so that it is quite easier to use. In simple words, we can define the data structure as it's the way of organizing data in such a way so that the data can be easier to use. Data can be easier to use. Simply, it is as the definition suggests, as the name suggests, data structure. It is the way of organizing the data in such a way that the data can be easier to use. It is a particular way of organizing data in a computer so that it can be used efficiently. Efficiency of a data structure can be measured with respect to time and space complexity. A scheme of organizing related pieces of information is also a data structure. The question arises, why data structure? What is the need of data structure? Human requirement. It is the requirement of the human being with computer are going to complex day by day. As we are all aware that lot many complex programs are going to be executed with the help of this data structure to solve the complex requirement in efficient way. Efficiency of the algorithm or efficiency of the data structure, or by which step you are executing that program, the efficiency is very important. That to solve the complex requirement in efficient way, we need this study. It provides the fastest solution of human requirement, whatever the requirement of the human beings. The data structure or the proper data structure can provide you the fastest solution. It also provides the efficient solution of complex problem by considering the time required and by considering the space, that is memory required for the execution of a particular problem. What we have to study in this data structure is logical or mathematical description of the structure, which implementation of the structure on a computer using various computer languages like C, C++, Java, Pascal, and many more languages. We can also do the quantitative analysis of the structure, which includes determining the amount of memory required or needed to store the structure and the time required to process the structure. In other words, we can also explain the definition of this time and space complexity is the time complexity can be defined as the time required to complete the process or to complete the execution of a process, and the memory or space complexity is called as the memory required or the amount of memory space required for the execution of that algorithm or of that problem. Classification of data structure, we can simply classify it with the help of this tree diagram. Data structure is more majorly divided into two different parts, that is simple data structure and compound data structure. In simple data structure, it is further divided into integer, floats, characters, pointers, etc. Whereas compound data structure is divided into two different major parts, that is linear data structure and non-linear data structure. Linear data structure can again be further divided into array, or the parts of or the types of linear data structure are array, linked list, stacks, queues, etc. Whereas non-linear data structure, it belongs to trees, graph, files, and etc. This is the whole classification of data structure. Basically, I have already explained in simple data structure and compound data structure. Simple data structure, whereas integer, floats, characters are the part of simple data structure, and linear and non-linear data structure are the part of compound data structure. There are various types of linear data structure and non-linear data structure. In linear data structure, array, linked list, stacks, and queues belongs to linear data structure. Then trees, graphs, and files belongs to non-linear data structure. The classification of this I am going to explain. Simple data structure can be constructed with the help of primitive data structure. A primitive data structure used to represent the standard data types, as we have already mentioned, of any one of the computer languages. It may be integer, it may be float, it may be character, etc. Whereas the compound data structure can be constructed with the help of any one of the primitive data structure, and it is having a specific functionality. It can be designed by user. It can be classified as linear or non-linear data structure, as I have already mentioned. A linear data structure traverses the data elements sequentially, in which only one data element can directly be reached. That is, it may be array, it may be linked list, or it may be stacks as well. Whereas non-linear data structure, every data item or every data element is attached to several other data items in a way that is specific for reflecting the relationship, in which the data items are not arranged in a sequential structure. That's why they are called it as non-linear data structure. For example, can assume tree as well as graph, that belongs to non-linear data structure. Operations on linear, non-linear data structures that we can perform. We can add or remove element, that means add element, or we can remove an element, or we can delete an element from the stack or from any type of linear data structure or non-linear data structure as well. An element can traverse, display, sort the list of elements. We can also perform searching and sorting in the list of elements, or we can also do the same procedure in terms of linear as well as non-linear data structure. Then the types of data structure, as we have mentioned, the first is, can go with the array first. Array is commonly used in computer programming to mean a continuous block of memory locations, where each memory location can store one fixed length data element, that is array of integers, array of characters, array of floats, etc. Similar data types. Then stack, it is a type of data structure in which items can be inserted or elements can be inserted only from one end and get items back from the same end. Means stack is open on only one end. There are the last item inserted into the stack, or the last element which is inserted into the stack is the first element to be taken out from the stack. In short, it is also called as last in first out type of or methodology. Queue, it is another type of data structure. A queue is a two-ended data structure which is in which the atoms can be inserted from one end and taken out from the other end. Therefore, the first atom inserted into the queue is the first atom to be taken out from the queue because it is open at both the ends. This property or this methodology that queue follows is called as first in, first out. Linked list is another method, another type of data structure in which clouds alternately used to store the elements. In linked list, space to store the atoms created as it mutates and destroy when the space no longer required to store the atom. Hence, the linked list is a dynamic data structure where space acquire only when needed. It is divided into two parts where the first is the actual value and another pointer that is having the address of the next location. Tree is another type of data structure. It is a nonlinear data structure which is mainly used to represent data containing the hierarchical relationship between the elements, and the binary tree is a tree such that every node has at most two childs. At most means maximum two childs, and each node is labeled as either left or right. You can see the next. This is the example of binary tree and general tree of as a type of data structure. In general tree, there may not be any restrictions of parents or there may not be any restrictions of children. It may have any number of children, any number of parents as well, where root node is having three different age, with the help of edges they are connected with their parent node, and they are again having their children, as well as we can also say it as the leaf node as well. On the right hand side of the screen, the binary tree, it means they are maximum, they are having two children, they may not have more than that. So root node is maximum, it may carry two children. They can further again divided or further again extended for their children nodes or for their leaf nodes, etc. Graph is another type of data structure. It is a set of atoms connected by edges where each element or atom is called as a vertex or node, whereas trees are just like a special kind of graph, we can also say. Graphs are usually represented by G, or G is equal to V comma E, where V is the vertices, set of vertices, and E is the set of edges. There are various types of graph. Undirected graph is on the screen. A graph whose edges are unordered pair of vertices. This is called it as the undirected graph, where there are no any directions given in for connecting the various vertices in the graph. Directed graph is having some directional edge connect to the two nodes or vertex. If there is one edge from one vertex to other, then only this path can be followed. This particular way is called it as the directed graph. In the weighted graph, a graph which is having weights or number associated with each edge is called as weighted graph. In the figure C, every edge is having the weight along with it, called it as the weighted graph. While selecting the data structure, we have to take care of these things. We have to analyze the problem to determine the resource constraints a solution must meet. We also have to determine the basic operation that must be supported. We also take care of quantify the resource constraints for each operations, and we select the data structure that best meets these requirements. According to these parameters, we have to select the particular data structure. That's it. Thank you for patience listening.